Okay, well, I guess on that note, we can go ahead and move over to Dr. John Peng with Orange County Public Works, who will be talking about Orange County initiatives for stormwater capture and infiltration. So you can take it away.
So for the presenters, I'm gonna actually share my screen, and for the audiences, you guys can just march forward with the slides. So let's see. Amir and Brett really did a very good introduction on the extreme event and urban drainage issues, and I'm actually going to talk about solutions, at least from the Orange County perspective. So next slide. I actually have 4 main topics. Since the flood risk already have been covered pretty well by Brett, Brett and Amir, I'm gonna actually go very quickly through that one. For LID and the related issue, since Brett also mentioned a little bit, I just want to discuss it from more of a water balance perspective. My focus will be on the Orange County Watershed Infiltration Hydromodification Management Plan, which is our version of the solution to the urban stream syndrome. And I'm going to talk about a case study. Because of the time limit, I actually thought about talking about the basin that Brett mentioned, but I'm going to just talk about a LID project that we're actually implementing. Okay, next slide. So the first topic, flood risk in Orange County. I'll go very quickly. The next slides, the Lamborghini submarine. So this one actually happened two months ago in San Diego. I don't know if this affect our Australian friends thought about stereotypes of Southern California residents, but this showed a Lamborghini actually driving mostly underwater at an intersection in San Diego. So I think the story is that flood risk, even in the dry Southern California, it's still very, very real, especially when people actually don't know how exactly to handle it. Next slide is 1938, the flood that Brett mentioned as well. This one actually is very much inland in Buena Park, and you can see that the whole area is underwater. And next slide, it is Huntington Beach, same flood, 1938. You can see that there is a large swath of water. Next slide, you can see this is Google Earth, and the highlighted area actually indicates the area that would have been underwater. So the point I want to make is that flood risk is real, and that's why our flood control district, working with the Army Corps of Engineers, to their main charge actually is to deal with it. Next slide is Orange County's flood zones. Basically, the purple area is the flood zone that's for 100-year flood, and the blue ones is for 500-year flood. Well, some people might think, well, that's a little bit extreme because 500 years, that's in terms of the possibility, that's pretty low. But because of the huge financial impact, economic impact, and social impact, we have to consider that. That's why in 1941 we built the Prado Dam, and more recently there is a Seven Oaks Dam. Prado Dam actually was approved in 1937, right before the 1938 flood, but it wasn't built in time, and it was finished in 1941. So unfortunately, but since then, only in 2005 there was a near bridge because of there are some issues. We had to release some water in 2005, and 3,000 people actually had to evacuate. So that's, again, a good example of flood risk. For Seven Oaks Dam, that's, the tallest dam, I think 550 feet tall, mainly to capture the flood water from the mountains. Next slide. Because of the all of these issues, Brett and Amir all talk about the risk and things like that. Brett also mentioned the levee effect. Really for all the Orange County residents having Prado Dam and the Seven Oaks Dam to protect the life and property, that's a really big deal. But for folks like flood control district, their main charge is to actually do that. Even though their main charge actually is to manage the floodplain, calculate hydrology. I think later on, let's see. Later on, Matt and Joe will talk about modeling approach. For flood control folks, they actually do similar things, focus on hydrology, and make sure that, as Brad mentioned, the capacity actually is larger than the flood flow. There is actually also water quality component for flood control, and that's actually what OC Watersheds, or right now we call ourselves OC Environmental Resources, do. So we were established in 2000. We had a different name. We changed the name a few times. Now we are called OC Environmental Resources. Established in 2000, our main charges, among many others, are watershed management and regulatory compliance. So next slides. I call it OC's 11 because we have 11 major watersheds from north to south, the Coyote Creek all the way to San Mateo. So these 11 major watersheds, there are also main stems of rivers and creeks. So these rivers and creeks are, what the flood control folks do the hydraulic calculation to make sure that the flood risk is managed. Every few years, they actually follow the land use change, development, and other changes so that to update the hydraulic calculation to make sure that the flood risk is managed. For our purposes, we divided into watersheds to manage the water quality more effectively. Next slides. Oh, we're gonna go to the urban water balance. Next slides, stormwater. So this slide showed the water balance perspective of stormwater. So basically, in an undeveloped area, when it rains, about a third go to evapotranspiration. 10% actually is overland flow. 40% goes underground as infiltration, and 20% is interflow. Basically, this flow actually goes underground, subsurface, and feed the dry weather flow of the creeks. However, when there is urban development, because of the large impervious surface, there is less evapotranspiration because there is not a lot of trees, less infiltration because of imperviousness. So there is very little groundwater supply, not much inflow because there's no infiltration. So most of the water actually go out as a surface flow to storm pipes, storm drains, and then into the ocean. And also the flow is very flashy because there is no retention by the permeable surface. So not only it creates a lot of problems for the flood control channels, it also causes erosion and carry pollutants to the receiving water and the ocean. So next slides. The same slides as Brett showed. So there are a series of urban stream syndromes and a cause of these syndromes. Next slides. But we can have design a number of ways actually to deal with them. to increase the infiltration. The bottom half actually showed how we deal with it in a if we do either low impact development or LID retrofit, or build community or complex to actually resolve the urban stream syndrome. So the different ways of doing that include green roof to promote evapotranspiration, more trees. Instead of impervious surface, we actually either break it apart, have places where the stormwater can infiltrate, or pervious surface so that we can promote infiltration. So in this, the bottom picture, there's more evapotranspiration, more infiltration, and there's a sizable interflow. And the surface flow out of this developed land actually is much smaller. Previously it's up to 75%. Now it's only 35%. Even though this is not exactly the pre-development hydrology, but it's close enough, and I would say this is the big step towards restoring the urban hydrology, but also the water quality as well. Let's see. So later on, I think Matt and Joe will talk about the modeling approach, how to actually implement from the, on a watershed level and achieve the desired benefit. Okay, so next slides, we're going to talk about Orange County Watershed Infiltration Hydromodification Management Plan. So basically, next slides, what I'm going to talk about is, from a watershed level, or this one is actually more than a watershed level. This is the county level, including 11 major watersheds. How we actually, do a county-wide evaluation, investigation, and studies to identify where are the areas where we can actually implement these different features. So, for LID, I think, different places call them different terms, but basically we try to use a number of ways to restore the hydrology to pre-urban, as I mentioned before. So here, what we do in a region-wide scale is actually take a look at different parameters, including soil permeability, the depth to groundwater contamination, landslide risk, and so on. Because even if you want to do LID, the site condition actually may not allow it, because I'm gonna go to the more details later on, but this is the tool that help us identify the priority areas where we can actually implement LID. And in a region-wide scale, if we implement different LID and other measurement measures on a regional scale, on a watershed scale, how we can restore the hydrology, reduce the flood risk, and improve the water quality. So these are the different points I'm going to touch on. Next slides. So this is the map showing the Orange County, soil types. The yellow brownish area actually shows the area with D soils. For folks who don't know how the Americans use the soil classification, D soil pretty much is the type of soil that has very little infiltration potential. So if you have this type of soil, if you pretty much you don't want to do infiltration. You probably can do other types, maybe capture, maybe reuse, but don't do infiltration because it's not gonna infiltrate. Next is landslide areas. So these areas where because of the slope or the other features like soil type. You don't want to do infiltration type of LID or even capture, because the land is susceptible to landslide. If it is saturated, there will be landslide. So you try to avoid these areas as well. Next slide is high groundwater areas. Brad mentioned, the Orange County, LA actually is a huge floodplain, and some areas, there are also shallow groundwater perched area. So you try to avoid these areas for infiltration as well, because when you try to use a swale or other features to infiltrate, actually, instead of infiltration, there will be groundwater intrusion. So you try to avoid this area as well. Next one. So there are also some areas in Orange County that the groundwater actually is contaminated, like El Toro, Swamp of the Frogs, and other areas where the groundwater is contaminated. So it just doesn't make sense for you to infiltrate and bring the groundwater contamination to a wider scale. So these are the factors you need to consider. And then with all of this information, you overlay the restrictions and figure out where the area is, what are the area you really want to do LID implementation, and figure out what, through the modeling approach that Matt and Joe is going to talk about, what are the receiving water benefits, and for our purposes, because we're heavily regulated, we want to make sure that for hydrology and water quality, we can actually achieve the target. So once we figure that out, okay, there are places where we can implement the LID or other water quality hydrology improvement projects. How are we going to deal with it? Well, not all the areas can be implemented because of the land ownership issue. So we actually focus on the public ownership parcels. This include, public open space, schools, and other places. Well, this is easiest to say than to be done, because even for public-owned places like schools, it's very difficult. But these are easier than the private-owned land. For private-owned land, mechanisms like public-private partnership or PPP is one of the mechanism where we can actually make it work. Next slides. Next slide showed the maximum percentage for each watershed that we can actually implement this LID features. After all, considering all the restrictions. For more inland or flat areas like Aliso Creek or Coyote Creek, we can actually implement a little bit more. For coastal or very hilly areas like Newport Coast, San Clemente, where we can do less. So these are actually the upper limit where we can do. It showed how challenging it is. It's very easy to visualize how much we could do, but there are a lot of restrictions. It will take decades of effort and billions of dollars to actually treat a certain amount of runoff and pollutant for each watershed. That's a lot of challenge. So last one, we should go. I'm going to talk about a case study about a project that happening right now, right here at our office building. So next slides showed a OC Public Works Glacial Yard campus LID building for United States and Canada, we call it LID. For Australia, I think it's called Water Sensitive Urban Design. England has a different name. US EPA actually prefer green infrastructure. For China, there is a pretty interesting name, Sponge City. But here, we have this LID campus project. I should mention that this is sponsored by the Prop 84 stormwater grant offered by California State Water Resource Control Board. I hope Brandon, the project manager, actually is among the audience. So basically, we have 3 parcels, 1, 2, 3. I'm actually sitting right in the building at parcel 1 at the upper left corner. This area is in the northern Orange County, and lower right corner actually shows the project site relative to Santa Ana River spreading basin, where if we do infiltration, actually this one can supply the groundwater basin. Next slide. So we got the grant, but to actually make it work, it needs a lot of work. On the left, you can see the soil testing, infiltration test, monitoring, survey. Now, actually, we actually built some, for one of the building, it's almost done. So on the upper right, you can see that some UCI grad student actually visited the site, and they tried to test the permeable concrete, but she actually didn't have enough water to actually create any runoff. So that's pretty impressive. Lower right is the on the top. That's the permeable asphalt, and on the bottom side, it's a just asphalt, regular asphalt, because it's a driveway. So you can see, I took the picture at the storm earlier this month. You can see the difference. For the permeable asphalt, there's just zero runoff, and actually the capacity is much, much higher than the storm. Well, looking at a grant scheme, even though this project cost 4.6 million in total, with 2.9 million from the state grant, state water board. If you look at the grant scheme, this is just a very tiny bit. So the red dots are the places where, as we went through the exercise I mentioned before, the red dots are the places where we can actually do LID implementation. And you can see that Glacial LID project site is just a very tiny red dot. So, can we actually, improve the water quality or hydrology in the humongous Santa Ana River watershed, which this site drains into? The answer is probably not. Just because of the scale of the project. So why are we doing this? Well, we do this because of many reasons. For this project alone, we can achieve. Next slide. We're now at the last slide. So even this project can treat 100% of the runoff and 85% retention on site, 95% pollutant removal. In a grand scheme, it is only a very small portion of the watershed. So what we really want to do is, through implementing this LID project, we not only gain insight on the construction, we test different type of LID. By the way, we're gonna implement pretty much all the different type of LID, with probably exception of green roof. There is permeable surfaces, there is ring tanks, flow-through planners, biofilters for infiltration and for research. We also gonna, do testing and monitoring, not just for the short time, but also for the long term as well. Monitoring, testing, operations, and maintenance. I think the real bright spot for our project is public education and research. We have a couple research projects already going on with Stan, and actually some researchers from China and maybe other places as well. So what we really want to do is actually use this one as a platform and educate the public. The public include also professionals, stormwater professionals, because they actually come to our office for meetings. And next month, for example, all the University of California campus stormwater environmental managers gonna actually tour the site. So, we actually gonna sponsor more researchers on our site. So the real incentive for us actually is to use this site as public education and research, so that other people can see and learn from our experience and from our data, so that we can implement the LID features throughout the watershed, throughout the county, and propagate the message to a wider world. So with that, I can take some questions.
Great, thank you, John. So we'll go ahead and open it up to questions. Get everyone unmuted again, and then we can open it up to questions.
Yeah, John, this is Brett. Can you say anything about similar projects in Orange County, or do you feel like you're right now the only major project like this trying to redevelop an existing development in this way? Or, I mean, do you know of any other development projects in the works, or any indication of whether this is gaining steam?
Well, I should say that our project is not the first one, not the biggest one, and it's not going to be the last one. I think, for example, city of Orange, city of Irvine, and city of Anaheim. I know there are many sites that are, they do a pretty good job in implementing. I think our project has a little bit higher profile for a number of reasons. The first, we get the money from the state, so that affords us to do different testing. We actually, including building the 8-cell biofilters where we can actually do some, research level work. We also, let's see, because we're ourselves are a stormwater agency, we actually have meetings of stormwater managers monthly. So this provides an excellent platform for getting the message out. That's why I think our project has a little bit better visibility. But there are many, many more projects being built, has been built, and planned in the future. So
okay.
That's a good question. Thank you.
Okay. Thanks.
I actually have a question, John. You showed a great graph that had the percent BMP covered.
Meg, I think you're broken off.
I think we might have lost some.
Yeah,
it looks like they dropped off for a second.
We try to guess which graph she's talking about.
I can guess. I can guess. Well, I think her question is about my, second to last. These are red dots where, these are the places where we're looking at implementing LID. The reason why these are just smaller than what we can see is that this is the overlay of many restrictions, and even for the places where we could implement, land ownership is a problem. So that's why these are separated and distributed dots. But there are different potentials to deal with them. For example, if we have a larger area where we can implement capture, that will bring a lot of water quality and hydrology benefit. We could also build multi-purpose BMPs, like we implemented one in South Orange County that has water quality, ecology, flood control, abatement, and things like that. So these are the opportunities that we try to explore.
So what you're saying is that in addition to the sort of the numbers that you were showing, say 30% for Newport Bay, for instance, you could do additional projects that were geared just towards water quality or something like that on top of those totals. That's from the bar graph that you showed.
Yeah, The bar graph showed, you know, for example, 30% for Newport Bay watershed. That means 30% of the area. This area, the runoff from this area can be fully captured.
I see. Okay.
And we can, you know, capturing means, you know, we could capture, infiltrate, and treat, and things like that. A number of options to deal with them.
Well, in the interest of moving things along, I suggest that first of all, we thank John for that really nice presentation.
Thank you.
And next, move on to Matt Burns down at Melbourne University, who's going to be talking about sort of watershed scale implementations of LID.